Questions?
Thank you for going over that.
Thank you. It's ugly. It's ugly because of these powers. Good. Next one. Anything else from 5.4? Anything else from 5.4? Okay, next problem. Anyone?
Can we go over number 15?
Yes, from which section?
From 5.4.
Very good. 15, 16, 17, okay. The area of the region that lies to the right of the y-axis, to the left of the parabola, yes. So the parabola is x equals 6y minus y squared in my case. The shaded region in the figure, yes, is given by the integral, very good, from 0 to 6, from 6y minus y squared dy, and you will do this in Calc 2, actually in the first chapter, chapter 6. Turn your head clockwise, and yes, so that's what you do. Okay. Find the area of the region. No problem. So let's do that. We copy 6. Which function prime is y? Remember, we increase the power, and we divide by that exact number, minus y. We increase the power by 1, and we divide by exactly that number, from 0 to 6. Let's simplify a little bit before we plug in. So this will be 3y squared minus y cubed divided by 3 from 0 to 6. Luckily, I don't have to plug in 0 because both will be 0. I only need to plug in 6. So it's 3 times 6 squared, which is 36, minus 6 to the third divided by 3. And minus when I plug in 0, but that's 0. So it's 108 minus, and I'll try to simplify, I don't want to multiply. So 6 times 36 actually divided by 3. So that's 72. So I get 36 as the final answer. And you are going to do this. This is the first application of integration. And it's in chapter 6 in Calc 2. Very good. Good question. Thank you. Anything else from this section? Last night somebody asked about 18, and I think it's a good problem to work on. We agree? We disagree?
Let's do it.
Good. So I'm on page 9. I am on 9. Okay. So bacterial population is 4,000 4,000 at time t equals 0. Even if I know anything about the problem or not, in my head, I already have this. It's a given ordered pair. Okay, and its rate of growth. And you will tell me what this represents. 1,000 times 5 to t, and it's bacteria per hour. What is the population after 1 hour? Find population after 1 hour. But we have to identify what this is. So read the problem and tell me what to write over there. Anyone? This should tell you exactly what it is. And there is one more word in there that it says rate of growth. So what do I put here? These two should tell us exactly what that is.
You mean if it's like a function of time or something?
Correct. But only specific functions have measurement unit as a ratio, and only specific functions are rates of change.
Delta derivative?
Yes,
Oh,
exactly. The derivative is the rate of change, and the derivative can have a measurement unit like this. If I have a measurement unit of bacteria with no rate of change, this cannot be the derivative. It's just a function. It gives the number of bacteria, population of bacteria. But once I'm told rate of change, and I'm told that the measurement unit of this function is bacteria per hour, I know for sure that it must be a rate of change, and the rate of change must be a derivative. Is that clear? Well, okay. So now I'm asked to find now the population, which is the number of bacteria, not bacteria per hour. But I'm asked to find the population and then evaluate it, blah, blah, blah. But what am I asked to find?
F of t.
Thank you very much. F of t will be the integral from 1,000, 5 to t dt. I will find the most general antiderivative, and at the end, in order to find the constant, what should I do? In order to find the constant, what will I do? Plug in.
0.
Yep. Good.
And
And 4,000 for the function. Yes. When time is 0, the function, the number of bacteria is 4,000. We're asked now to find what happens, what is the number of bacteria when an hour passed. Not 0 comma 4,000, but 1 comma blah. Okay, so I take the constant in front, of course. The integral from 5 to t dt. And now the question is, what function prime here is 5 to t? And I can go back to explain how we get that. And it all is connected to e to the x. E to the x prime is e to the x. I should write times natural log e, but there is no need because it's 1. But when I differentiate any other number raised to x, what do we get?
a to the number times the natural log of the
Very good. Very good. So now I only want this. So obviously I have to divide by natural log A. So this is 5 to t over natural log 5. And we can check. This is a constant. When I differentiate 5 to t, I have 5 to t times natural log t, which will simplify, natural log a, natural log 5, which will simplify. So this is it. When I differentiate this, I get that. And 1,000 is 1,000. At this point, I will plug in 0. I will get for the function 4,000, and then that will enable us to find the constant. So we know that f of 0 equals 4,000. So here's the function. So I plug in 0. 5 to 0 is 1. So 1,000 divided by natural log 5 plus a constant equals 4,000. So f of 0, 0 here, this is 1. 1,000 over natural log 5 plus a constant equals 4,000. So now c equals 4,000 minus 1,000 over natural log 5. After all this work, I do have f of t, which is 1,000 times 5 to t over natural log 5 plus the constant plus 4,000 minus 1,000 over natural log 5. We found the function that gives the population at any time t, but they only want us to find the answer after 1 hour. So all I have to do is just plug in 1. So when I plug in 1, this is 5,000 over natural log 5, minus 1,000 over natural log 5 is 4,000 over natural log 5 plus 4,000. 5,000 minus 1,000, because they have the same denominator, is 4,000 plus 4,000. I don't know what this is. So 4,000 divided by natural log 5 and plus 4,000. I got 6,485. Let's see what they want. Round your answer to the nearest whole number, of course. The nearest whole number is 6,485. Because we can have a bacteria and a half. Like we cannot have a person and a half or 5 cats, 0.3. 5.3 cats. Good. Next question. From anything. Anything, any section, any question. Type 1, part 3, May the 6th. Any question? We move on to the next section.
Yeah, that might be a good
Okay.
idea.
Very good. So let's move on to 5.5. Let's click on it. Anything?
Maybe something like number 8. 8. Good.
Number 8, very good. So the integral, number 8?
Yep.
Oops, I'm sorry, I was copying 6. Sorry. So the integral from, what I see is, if you want me to change any of this, I don't want to do my problem. I would like to help you with your problem, but it's up to you. Maybe this is better to choose a problem so you know what to expect. Okay, yes?
I think mine is exactly mine's the same.
Okay, very good. So here we're asked to find the indefinite integral. This is nice because whatever I get is going to be a family of functions, and I can differentiate to check my work. If it's a definite integral, I cannot. Okay, so I'm trying to simplify everything here, and I realize that if I use, can anyone give us a possible substitution? And then we'll talk about it. What could be the substitution?
9 minus e?
Yes,
Or
9 minus e to u. I would recommend that. Only if dy is in the problem. So please give me the differential, not the derivative, the differential of this function. And what will I write?
so negative e to the
Yes,
y? Oh, e to the u times du.
exactly.
Oh.
Is this in the problem? Of course it is. I only need to multiply by -1 twice. So now this is all this. So we have a minus in front. We have the indefinite integral. And what do I write? What is this now? All this is dy. And what is this denominator?
So dy over y squared.
Excellent. Very good. So now I'm going to copy it because I ran out of room like I always do, almost. So it's negative the integral from dy over y squared. And we know which function prime, I don't want to write that, I should erase it. Which function prime will be negative 1 over y squared? Because I think I made my case throughout the semester for that specific one.
1 over 1.
Excellent. This is very important. That's why I tortured you with this all along, because now I know that 1 over y prime is negative 1 over y squared. So it makes my life much easier. Yes, I have to go back to the function because it's an indefinite integral, and I have to present the answer in the variable that was given in the problem. If it's a definite integral, who cares? It's a number. But now I have to go back and rewrite 1 over 9 minus e to u plus a constant c. Anything else?